Welcome back to the second part of the Satisfactory tutorial. In this part, we're going to be making the conveyor belt. So it's actually going to be a runtime conveyor belt, unlike what you see in most other tutorials. So it's something that the player can actually control, and we're going to create it so that it adapts to wherever the player rotates it and orients the direction of the conveyor. So to start off, we're going to get some stuff out of the way immediately, and that's going to be the assets and the materials. So to start that, we're going to go ahead and import the three parts that we'll need. So that's the conveyor belt start, the conveyor belt middle, and the conveyor belt end. Because due to how normals work, we have to have them separate, because the middle will have no, how to put it, we're going to have holes on the edge. So I'll just show you that. It's pretty clear. Just close that. So we don't actually see through here, because otherwise in the hologram version you would actually see a kind of line here and it'd look weird. So I just made three different versions so that we don't have that issue. So for the materials, it did go ahead and create two basic ones, but we're not going to use them at all. So we're going to force delete them, and we're just going to need to make one material here. So that material is going to be a conveyor material. So let's start by creating that. So a material m_conveyor belt, we'll call it. And this is just going to be similar to the hologram. It's going to be a material that moves, so that we can actually see how it goes along the conveyor belt in the right direction. So to start, we need to make sure that we enable it for conveyor belts. So for our, let's say, there it is. We're looking for our spline mesh here. So that's what we want to tick. We don't need to do instance this time because it's just going to be a spline mesh. So we can apply, and for the material, we're going to do something rather simple. We're going to get a texture sample with T. We're going to be looking for, in my case, I use the default, if I remember well, and we're going to take default alpha texture. It's just a random one. Anyone is okay, but I chose this one because it's pretty simple to see how it's moving without being too overwhelming. So we want to multiply this because we want to actually tile it out a bit so that it's more visible. So you can leave this here. Next, we want to get a panner node, which is going to make it actually move. And for the speed, we want to make an append vector because we want to have two different components, because you only want to move it in one direction. So first we want a float, hold down 1 and click, and we'll leave that at 0. So this will be the velocity on the x, and then we want the velocity on the y. So we're going to do one last multiply, because we actually need to multiply it negatively, so that's in the right direction relative to our UVs. So put -1 here, and hold S to get a scale parameter, which we'll call speed. By default, we'll put that to 0.02, and if we apply it here, we'll be able to see the actual material moving. Now it's very slow, but we made it a parameter so we can actually change it later. So we can compile and save this, and once it's finished loading, we're going to go in and do one little change that I forgot to do actually in the last video for the actual conveyor belt. So let's just save that. So in the last video, we made our parent class for the blueprint. So I actually made a slight mistake here, where in the event begin play, so event graph here, we removed it, but we actually do need the event begin play, and we need to call our create build. Because if we don't actually call this, in our case for the build support, it works automatically because it looks like this to start, and then we update it with our inputs, so it's fine. But in the case of the conveyor, which we're going to make now, it won't work because we don't actually have it visible yet. So let's get into that. If I'm remembering correctly, we can immediately start. So we're going to right click on our A builds, and we're going to say create child blueprint. So A_builds again, and this time it's going to be conveyor. So save that. Now I'm just going to go into Satisfactory, the character, our FPS, and just tell it that when we press 2, and actually I also made a mistake here, we want to put this on started, and the same here, obviously. And this time we select conveyor. And we want to do the same thing for our confirm. Now the reason for this is that if we do triggered, it will just be, as long as we hold it down, it will keep calling it. So that can lead to some issues, which I should have actually done before. And we'll do the same thing here, just to make it easier or smoother more like. So compile and save, we won't need our character after this anymore. Okay, so now we can get straight into our conveyor. Straight away, we don't have anything else we need to touch because we've set it all up before. So I'm just going to open it on the other side to make sure I make as little mistakes as possible. So for the conveyor, we're going to need to go through most of the functions that we've already made again. So we're going to start going through them by starting with, let's say, create build. So actually, maybe before we do that, we should do the components and the actual variables. So for the components, we're going to start with a simple spline. That's going to be our actual spline that we can see here, and that's going to be the shape we're going to move. Next, we want to actually add a second thing, which is a static mesh. And this static mesh we're going to call temp underscore conveyor. Now this conveyor is very simply going to be used just to indicate which direction we're facing when we spawn it initially. So we're going to set this to our conveyor, and we're going to use start. So it should appear like this, and for the material we'll be setting that in a second. So we're just going to compile and save here. And if I remember correctly, we have our conveyor belt here, and that's all we need to do. Actually, we need to change its collision if I'm correct, because otherwise it will block or bump into the player while placing, and that can cause a lot of issues with the players being sent flying for no reason. So we just put it to no collision. We're not going to be changing that at all throughout the tutorial, because even later we'll just delete it simply. So let's get to our variables here. So for the variables, we have a handful we need to actually make. So the first one is going to be one we'll call section length. And this is going to be by default 100. We're not going to touch it, because what it is it's how long the actual conveyor belts are. So the actual static mesh is 100 units long. So that's what this is for. We're going to be modifying it when we actually start placing them, because I discovered, or for while testing, it's more interesting to actually do an average as close as possible to 100, because otherwise sometimes you might end up with one of almost double the distance, which is a bit weird and sometimes can cause some visual glitches. So we'll do that later. For the other variables, we have one we'll call start support, which is going to be of type A build, and then we're looking for our support. Another one of the same type, which we'll call end support, and I'll be explaining both what these are used for when we actually place them in. Then we want a very basic boolean, which we'll call start locked, and it's going to be a boolean. Then we want another map here, or we're going to need a map here, sorry, and it's going to be called spline mesh comps, and it's going to be of type spline mesh, and we want component. And we're then going to turn this into a map, and on the other end of the map we're going to get a 2D vector. Go save it like that. And I'm actually going to put all of these into our placement, and that way they're all in the same spot. Let's just move them all there. And we only need one last thing, and that we're going to make here because it's a variable, it's easier made here. We're going to say create dynamic material instance, and the material instance we'll use is what we created, and it's the conveyor belt material. I'm going to call it conveyor belts, and we'll call it M underscore, or MI for material instance. And we're going to promote this to a variable, which we will call MI conveyor belts. Okay, so that does it for all our variables. We have nothing else we need to create there. Next is the functions. So first we're going to go over all the functions that are parented from our parent class, and then we'll go into the new ones that we need to make. So to start off, we'll start with our create build. Actually, maybe we'll do this first. So we're going to make actually a quick macro, which we'll call move start. So what this macro does is going to simply take in our start locked here, make a branch, and it's going to go input there and output there. This is just so that we don't have to keep copying and pasting this, and we can just have one thing for it. What we want to do is this will, if it's true, then we move end. If it's false, then we are moving the start. So we can compile and save. So this is just pretty much when we start moving an object, when we create an object, a build. With the conveyor, we actually just want to move the initial point first. We don't want to touch the final point. But once we want to start moving the second part, like the ending of the conveyor belt, we need to fix the start. So it's kind of two different movements, and we're going to make the difference in our code with this. So let's close that. And now we can move to our create build. So create build is pretty simple. We're going to spawn an actor from class, or yes, actor from class. And we're looking for a build, and we're looking for our support. Now with this support, we're going to actually, we might need to make some changes, but for now we'll keep going with this. We need to get actor transform, and in the actor transform, that's all we need, and we're going to promote this to our start support. So what this is for is so that when we place or start placing our conveyor belt, it actually has a support like we made in the last part that is set up for it. We then want to set all materials for this, and we want to set them all to our MI hologram, which we made in our parent class. So that's all we have to do for the create build. Next, we have our place build, and I think this one gets a bit more complicated. So the place build is, we're going to start off, it's going to be the first place. We actually need our macro here. So let's call it, and we will start with obviously moving the start. So what this means is if we call here, that means we've left clicked, so we've confirmed our movement, and we want to lock in the beginning. This one here will be for once we want to finally build it and finish the whole thing. So we're going to make a sequence. On the end of the sequence, we're going to simply call start locked. We're going to say it's true because we just finished the beginning and we don't want it to move anymore. And then we're going to add our return node here. And this is the reason we have a boolean here, is to tell that yes, we have finished placing, but we still want to continue with our code in the first person character, because we still want to keep actually moving it instead of canceling and recalling it. So once we do that, we need to now add a second support. So back in our create build, we can actually copy this because it's exactly the same. And we want to place this here. And we're simply going to replace the start by our end support. We can then also, obviously, once we start doing this, is we're going to start showing our actual conveyor. So we no longer need our temp conveyor, and we can say destroy component. And the last thing we're going to need here before we do all this is we're going to need to set up our tangents. So this is pretty much just to indicate which direction the beginning will be facing. So we're going to call set tangents at spline point. Make sure you use the plural. You'll have in and you'll have the arrive and leave. Otherwise you'll just have tangent. And what we want to get is we want to get actor forward vector. And we're going to multiply this by 100. So to do that, we want to right click and convert the pin to a float. Attach both of these into our arrive and leave. Actually, if you attach it, it will reset it. And we want to set it to 100. Now, one thing to make sure is that we want to be sure that this is in world space. We're going to be swapping between these in other scenarios, but here we want it to be world. So with that, we finished our actual start one. So now let's move on to the end. So for the end, we're going to need, once again, another sequence. So we'll hold S and place that. For the sequence this time we want 2 different pieces. The second one here is going to be, we're going to need an actual new function. So I'm going to make that very quickly, which we'll call place support. Now place support is going to take in our, actually we can do it this way, get a quick result. Drag the pin to the beginning and it will create our parameter for us. So this is the support. Now this function is pretty simple, so we'll just do it now. We want to check actor hidden in game and put a boolean. Now we're not actually going to be using this yet. I'm going to place it, but it's going to be for the next part, because if I did do this part now, we would end up with a 2-hour video and that's a bit too much. So here we want to call place build, and for the target we're actually going to use our support here. Make sure you use the actual parameter. Then with support, if it is hidden, we're going to destroy actor. So for a heads up for what this is used for, it's pretty much when we currently right now what we're going to do is we're going to place the support every time, as in we're going to make it visible and have it be there whenever we move our conveyor belt. But if, for instance, you want to connect a conveyor belt to another one, well, you don't need that support. So we're going to set that up next time, but this is the basis for it. So we're going to call that here twice, one for the start and one for the end. And we're going to plug them in to each of them. So this goes to the 1 and this goes to the 2. Well, no, both of them go to the same thing, sorry. Then what we need to do is we're going to do our actual first node, 0. So for the 0, what we want to do is we want to get a reference to our spline mesh here. And we're going to get our keys and plug that into the then. And we're going to do a for each loop. Now, what we're doing here is simply we're going to be setting up the materials and resetting the collisions. So we're going to call set collision enabled and set it to physics and query. So collision enabled. Then from the array elements again, we'll say set collision response to all channels. Sorry, not 2 channels, but response to all channels and put block. This is because when we're moving it, we don't want it to hit the player. So we could do that. And finally, we want to set material, and the material will be number 0 here. We're going to use the default material. So this one right here. Anyone does work. It's just we're going to use this one as a basis. And for number 1, so the second material, because there's actually 2 for each conveyor belt, we're going to set material again. And make sure you set the array index to 1. And here we're going to get our MI conveyor belt. Connect it all. And we're done with our place build. So next up we have, so actually let's just move this in there as well. Next function we want to work on is the cancel build. So let's call that one as well. Actually in place build I think we left this, we don't need that. So in our cancel build, I think it's very simple. We don't have to change much. We just need to inform it if our what's it called? If we have our support, we need to get rid of them. So we're going to need 3 nodes here just to make it tidy. At the end, make sure this one is on the second one at the end here. Otherwise, it means you're deleting it and the rest of the code can't run. So we're going to call start support and end support and make sure that they're a validated get. So let's plug them both in here. You can do this in any order, this one doesn't matter. And we're simply going to call destroy actor if it's valid, and the same for the end support. Just move that to the side. And there we go. So that's for the cancel build, pretty simple. So moving on, next is the update function. So for the update function, it's where most of the changes are going to happen, but I made smaller functions because they're needed because of all the stuff in it to make it more readable. So we're just going to make first the original one. I think we'll go through the rest first because we need quite a few smaller functions to get it all to work. So we're going to override our update location here. So at the end, update location. We can close our placement. So for the update location, we're going to start off by promoting this to a variable. local one we'll call L hit info and leave it there. Then we're going to get our macro again, because this is specifically where we need it. For the start, all we're going to do, very simply, we're going to get our start support, and we're going to say update location. And it's going to use our hit info here. So let's do that. And what we need to do for that is we simply need to call this actor here, so our self, and say set actor location and rotation. And what we're going to use is we're going to use our actual location and rotation from our start support, but we want to get specifically the attach point. So we get that, and we want the get world transform. Sorry, I mistyped that. There we go. So get world transform. We're going to break it. Sorry, break it. And we simply attach our location and rotation to it. Let's just make that all lined up. There we go. So that does it for the actual start. So that's pretty easy. Normally, if everything is done now, we should be able to press 2 and we can move around with our thing. Now, currently nothing else happens. If we rotate, it's going to do like it originally did, but because our location is updating the actual spline, it doesn't rotate correctly, but we're going to be fixing that in a bit. So now we're going to do the end. So for the end, here it's going to be look pretty easy, because we're going to have some smaller functions to deal with the complicated stuff. There's going to be a lot of spaghetti code in this part. So here what we're going to do first is we're going to update our end support. So we're going to call update location. Then we're going to get our hit information again and plug it into the then. Let's go there. And once again, now here we're going to need a new function. But to do that, we're actually going to make it here and collapse it. I'm not sure if it's used multiple times. I'll double check. If it isn't, then we only need it once. So actually, we only need it once here, so we're not going to make a function out of it. So the first thing we want to do here is we're going to need our first sub function. Now, it's because it's not very difficult, but we're going to be using it so much that we're going to make a function out of it. It's going to be called get last spline point. And it's pretty indicative of what it does. It's going to get our spline here and get the last point in it. So it's going to return an integer, just call it return value, because that's pretty much what it is. We want to get spline points, and this will give us get number of spline points. And we want to subtract 1 from this, so that it gives us the last index of the spline. So we compile and close this, we don't need it anymore. And now we can do the next part. So what we're going to do here, we're going to get our end support again, copy, and this time we want to get attach point as well, but instead of getting our transform, we're going to get world location, and then we're going to get the forward vector. So get forward vector, because we're going to need to set the actual endpoint of our spline here and tell it to move relative to our attach point on the support that we're going to move. So we're going to call our get last spline points, our spline, and we're going to say set location at spline points. The spline point is our last point here, attach that here. And for the location, we have that right here. Now, we also need to do the same thing, but for our what's it called, our not normals but our tangents. So for that, we're going to multiply this by 100 again. Let's go and do that here, put a float 100, and we're going to call these two again and say set tangents at spline point. Once again, for the point index, we'll use that, and for the tangents, we'll use this. Now, we want to make sure both of these are set to world, so make sure that they are here. And we're going to move on to our next part. So I'm just double checking that I got everything right here. Yes, I did, so that's good. And okay, so for the rest of update location, we're going to need here 2 new functions. The first one we'll call update spline shape. The second one we'll call update spline visuals. and they're going to be put in that same order. We want to update the shape first, and then we want to update the visual. Now, once that's done, we want to call our material for the hologram, get mi hologram, and we're going to have to set its vector parameter value, and this is going to be the color. So this is just going to actively check whether we can place or not. We're using our function IsBuildable. So then what we want to do is we want to use a select here, and select color, and we'll simply just put on A true, meaning it is buildable. We'll just put blue to 1. On B, we'll put red to 1. So let's align all these up. And with that, we're done with our update location. This will be where most of the code is going to be. So we're going to move past this for now. We're going to go and do one last function in the update, which is the set materials. And I'm just going to place these in here. So for the set all materials, we want to detach this and put a branch. And on default, we need to make a little change because we have these two instead of what the parent does. So we want to get override material here. And on false, we'll simply call the parent. We don't need to modify it. It works perfectly fine. But here, what we need to do is we're going to get our, I believe we did it already in the place build. Yeah, so we're just going to copy pretty much this like that. So copy specifically these 4 or 5 nodes and paste them in here because we only want to change the material here. That's all we want to do. So we have our keys, we have our loop, and we simply want to plug both of these into here. Now, on the other hand, this time we don't want to use, actually, no, sorry, if it's default, then we do want to use our actual material belt here. So that does our materials. Next we have our scroll functions. So let's get both of those. Let's get our scroll. It should be scroll build and scroll custom build. So pretty much what we're going to use is we're going to use our supports here and modify them. So because everything else is attached to those points, then we can just use them here and modify them instead. But we do need to use our macro because it depends which one we'll modify. So on scroll build, we want to call from our start support, we want to call scroll build. Make sure it's attached to the start, and we'll call our mouse input here. We can align those, we can copy it and simply right click start support and change it to end support. Connect them like that, and we are done. We can then, we'll copy this because it's very similar. We just need to change the actual function, delete our parent class, and paste it here. So apparently it doesn't recognize this. Let's see if we can refresh. No, so we'll have to call it again anyway. So we'll get mouse input again, but this time instead of scroll, we need to scroll the custom. So this is the one that changes the height in the support. So we'll copy this again and do the same trick here. We'll just replace start support with our end support. Compile and save, and that will do it for our scroll. So next, I think if I'm correct, we have our IsBuildable function, which we need to override as well, but I'm definitely going to leave that alone. That's going to be the last thing we're going to touch because we need to make quite a lot of work there. So next, I guess we're going to make all our smaller functions because we're going to need quite a few of those to work through the rest. So for those functions, we're going to need to call, let me check. So we're going to create a new category here, which we'll call Spline, but we're going to start with the first function. So the first function we made was get Spline points. So we'll actually call this in Spline category. So that one's done. Got that one out of the way. Next, we want to call another one, which we're going to call is in front of actor. Of actor. Now, let me just double check this is actually used. So actually, so get rid of that one. So next, what we need to make is we're going to need Okay, so now we're going to need a function pretty much that's just going to get us all the information from a spline point in one place. So what we want is we want to call it get spline info at point. So just think of this as, instead of saying get transform, get tangent, and all that, we're just going to call it once here in a function and it will give us everything. So we need to add a return value here. We're going to turn it into a pure as well. And instead of typing them all one by one, which one we need, we're going to get the spline, and we're going to call get transform at spline point. And so one of the returns will be that. Then we want to do the same thing with the spline, and we'll call get tangent at spline point once again. And this one will go here, and we're going to also normalize it so that we have a normal vector of it. So we're going to call this transform. We're going to call return 1 to tangent, and the second one we'll call normal, or more like forward vector is better. We'll call forward vector here. And with that, we just want to connect our point index here. Same thing here, and we want to make sure that we connect this as well. We can compile and save and make sure, yeah, that we've already made it pure. Okay. Next function we're going to need is we're going to want at certain points to get the distance between two specific points. So to do that, we'll create a function we'll call get dist, not twice, just one, dist between 2 points. Put that once again in the spline, and it's going to take in three inputs. The index A, the index B, and we're going to put a absolute. So the reason we want an absolute is in some scenarios we want to have just specifically the length value and not the actual direction of it. So with these, we're going to get a reference to our spline, and we're going to say get distance along spline at point. And we're going to call it for both of these. So we're going to get index A, so get that, and get index B, so get index B. And with both of these, we can then align them all up. And we're going to subtract, and this will give us the distance, and we can then say absolute. So make sure you have A at the top and B at the bottom, otherwise you'll get the opposite of what I have. And if we're trying to follow along together, then that might be complicated. So we want to select this float, and we're going to get our absolute boolean. And if it is an absolute, then we want to use that. If not, we want to connect the B. And then we'll put this in return. We'll simply feed our return value into it. Compile and save. Next, we want to get another function we'll call get relative rotation, and we're going to have another one for get relative location. So get relative location. For the relative rotation, it's pretty simple. We just want to call for our get last spline point here. We want to call get rotation at spline points. Usually if you type it, it should automatically fill in that we're using the spline here. And we want to break this because all we're looking for is the actual Z. We don't care about how it rotates on the roll and the pitch. We just want to know on the yaw. So we put this as a return value and plug it in here. Let's compile and save, make it a pure one actually. That's for distance as well. Sorry, we want to do pure. Pretty much all of these are going to be pure casts. Or pure functions, sorry. Let's save that. And for location, we'll do the same trick. Copy paste that, place it here. And for the location, we want to do the same thing, except we're going to use X and Y this time and not Z. And also make sure that we have it in local. So get location at spline points. By default, it is local, so there's no need to go back. We did do it for the other one automatically without changing it. We want to break the vector, and we're then going to say return node, and we want to return the X and the Y. Compile and save. And now we have two more functions left. And these two functions use pretty much the same trick as this one, but we're going to be using it as well. One of the functions will just duplicate this and we'll call get, I put end quad. So it's pretty much to tell us if we're in front right, in front left, or behind left, behind right, relative to where we started. And so instead of just what we'll do, and we'll remove this and we'll just call out get relative location here. And we want to clamp the float pretty much. And we're going to use it for both. There we go. And we want to clamp it between -1 and 1 for both of them and plug them into X and Y. And finally, the last one we want is we want to get a direct, something similar to what we have here, but this one does measure along the actual spline, so the actual distance on length of the spline itself. We want another one that just measures immediately the actual distance between both points in a straight line. So we're going to create that one, and it's going to be once again a float at the end, so we'll just copy this one. No, which one do we have? That's just a float. Okay, we'll copy the relative rotation. And we'll call it get linear distance of spline. Because we're not doing it between 2 points here, we just want to know for the last point, we want to get location at spline point. And we want the last point here, which is why we use that. And we simply want to get the length of the vector. So get vector length. Plug that into here, and we'll change this to return value. Now, with that, we've finished all the setup functions, all the extra functions that we will need throughout this thing. And now we can get into the actual hard stuff, the stuff that's actually difficult and a bit more complicated. It took me quite a while to get this, but hopefully it's clear enough that you'll understand, because it's going to be some really nice spaghetti. We're going to have some really nice spaghetti here. So we're going to start off with a sequence to make the spaghetti a bit more readable. And we're going to start off with a branch here. And we're going to drag the branch out because we're going to need a lot of space here. So the first branch, what we're going to do here is we want to check whether the spline is a certain distance. So if it has a certain amount of points, sorry. So we want to get number of spline points. And we want to check if it's inferior to number 3. So by default, the spline point you have 0 and you have 1, and that will return a number of 2. So what we're going to do here is, if we are at 2, we want to actually make a new point. So to make that new point, what we're going to do is we're going to add a point to our spline. Very simply, we're going to say add spline, sorry, not like that, add spline point. Now it doesn't need a specific index because we will be modifying the indexes later. So for the position, we need to put something in here. So what we'll do is we'll get our get spline info, and we're going to simply put in 0.0. It doesn't really matter because once we create a spline, it'll take a new index and we're going to modify that index immediately after. The only case is for this one, because it's the start point, it's always going to be at the start. We never want to move it. So this part actually could probably be moved to when we create it, but it does need to change sometimes with the tangent. So we're going to be doing that after. So we want to split our transform here, and we're going to use our forward vector and multiply that by 100, because we want it to be 100 units in front of where the starting point is. So we will do an addition here and connect it to the position. And that will do it for our first line here. So we can drag that out just a little bit, have a bit more space. Make sure that we're in local this time, because we're using the forward vector, but we're using the transform location. And it's the forward vector of the specific spline point. And because we haven't changed this, we're still in local space. Now, on the other hand, if we do have this point that already exists, we want to tell it to move and adapt to what we want. So in that case, we're going to say set tangents at spline point, and it's going to be at spline point 1, because it's the next index right after the actual spawn or the start. So it's number 1, and number 2 at this point is the end. So we want once again a reference to our get spline point here, but we don't need the transform this time, so we can recombine it. And what we want to do is with our forward vector, we want to multiply it and attach it in here. Now, instead of what we did before, we just did it by 100, we actually need to put a specific value here. So we're going to get our distance between 2 points. And this is going to be the value we put in, but we do want to clamp it at a certain value because we want to make sure that it never goes over a certain threshold, and that is going to be of 500. We'll set it to absolute because we know that it's always in front, so we don't need to bother with that. Index will be 1, and we're going to use the endpoint 2. So this will get us the distance between the midpoint, let's say. So next what we want to do is call this here, just move it a bit closer, and with this we finish setting up our first point. The reason we do this is so that it's a bit of a smoother curve. If you have, for instance, let's say instead of going perfectly straight, we go slightly off to the right or slightly off to the left, it will have a nice curve where the end will always be straight because it's attached to a second point, which it will curve, or cause the curve, more like be affected by it. So next what we want to do is we want to do pretty much the same thing, but for the bottom. So, or for the endpoint. So we can copy this. Let's just actually move this a little bit further. We'll copy this to the bottom here and just, actually maybe to make this easier, we'll put a second sequence here. Make it a bit easier to read. So this is just going to be for the main points. So we attach this here. It's almost identical, except this time we're not looking for point 3, we're looking for whether we have 4 points. And instead of using the start, we're going to use the get last spline point. And we'll pretty much do the same thing, except instead of plus 100, we want minus 100. For the tangent itself, we want to replace u with our get last spline here, minus 1, because it's the before last one we want to use, or modify more like. And we'll use this here again for the point. And the same trick here, except instead of 1, we're going to use the minus 1 here. So this is going to be checking the distance between the last two pretty much. The before last and the second point. Once again, capped off at 100, absolute. And next we actually also need to move it, because this time we can't just place it once and leave it there. So now we need to call this down here and tie it to update. So do that, we're going to get a reference to this. We can copy this, it's the same thing. Actually, no, sorry, because that's just add spline point. We want to set spline point, spline location at point. Let's plug this in here. And for the point, we're going to use our minus 1 here again. Plug that there. And we're going to be using this once again. And what we'll do for the location is the same trick as we did actually here. We can copy that and we will move it, and we're going to be placing it pretty much at the exact same spot as what we did above. Let's place it here. There we go. Now, so that does it for our main points. And if we have a look now, if we run a test, if we place it, right now we can't see anything, but this is the effect it has. So it kind of puts a point here in front of it and adjusts the curve accordingly. So I think we have a bit of a mistake here because the curve is going further than it should. And I feel like I forgot something that I did last time as well. Like right now we have this weird problem where it goes back, which is a bit strange. So I'll have to double check if I did this correctly. Okay, so I figured out what the issue was. So the issue is actually this function right here. We need to actually change it with add spline point add index and make sure you select 1. So for some reason it obviously doesn't like it, and that makes, I can kind of understand this because we don't tell it which one we're setting, but here it doesn't matter because here we're actually telling it which one to update after, but here we're not actually telling it that, so that's why it bugged out. Let's try that again, and now it should be working perfectly. Okay, so it's working as intended now. So we can move on now finally to the next part. So next up, if we've set this all correctly, yep, we did, it all works. Next up is the long part. So this is going to be the longest part because this is pretty good. It'll work pretty well for most scenarios, but if you start to do things like rotating the actual thing, here it looks okay, but if you start to, for instance, tell it to go like that, it will start having a bit of trouble. Mainly, specifically, if I do that. Here, the line will actually look really weird and won't work correctly. So what we're pretty much going to do here is we're going to inform it that it can add another point here and add a middle point here to make it more smoothed out. And that's what we're going to be working on now. So from our initial sequence here, we're going to remove the second one. We're going to go in and we're going to check if the actual rotation is different, because that's what we need to know. If the rotation is of 180 degrees, because if it's 90, 135, it's fine. It will manage pretty much as long as you don't do something really crazy or really sharp. It'll be fine, but we're going to tell it that you can't place it like that, so it will work. So we want to get our relative rotation here, and we're going to go and call absolute, because we want to know if it's minus 180 or 180, it doesn't matter. And we're going to look for nearly equal, because if you don't do nearly equal, it doesn't seem to like it and will not notice the issue. Double check, we need to go a bit lower than that, or we're going to run into that here. So once we have nearly equal, we want to do on false, we're going to call a while loop, which is simply going to be used to actually destroy what we don't want. So we'll call our spline here, we'll get number of spline points, and if it is superior or equal, then we're going to destroy it. So we're going to say if it's superior or equal to 5. And what that will do, we'll call here, we'll say remove spline point. Now the reason we're not doing this in any of the other cases is because we always want there to be those extra 2. Then we want to remove index number 2. Now on the true, so on we are equal to 180, so we've done a complete turn, we want to add a sequence. So the first sequence will be about adding the middle point, if I'm correct, or... So no, it's not as simple as that. So we'll want this again, and just like before, so that we can create our points, we'll use number 5 this time, because it's the 5th point. So for the 5th point, we want to add it here. And what we want to do, same trick as before, we're going to say add spline points like this. And this time we'll just leave it at 0. We're not going to bother with a specific number because we're going to be modifying it right after anyway. So go like that, align it, and we can leave it like this. It's not going to matter too much here. So this will be adding our point, because no matter the scenario, we need to add at least 1 point. But next we're going to do the different scenarios, because you can't add the point at the same spot if you move on the right or if you move on the left. Sorry, no, not the right and left, the back or forwards, because otherwise it will end up looking pretty weird and not correct. So what we need to check here is we're going to check the actual relative location. So get relative location, x and y, put a branch. And what we're going to simply look for is we're going to say if x is superior or equal, if x is inferior or equal to 100, and if x is superior or equal to minus 100. So the reason we do this is just to check that if we're very close to the initial starting point, there's no point in actually doing this. We'll just leave it with the middle point. That'll be fine. So we call our condition. And we want to now do the same trick as we did before with the other one. So with this. So we'll just copy this because we're going to create one more point again. And we're going to have to make another one after. So this time it's going to be 5, if I'm correct. Okay, so maybe that's not correct. Sorry, no, this is correct. But unlike before, we're not going to add, we're going to remove this. So if 5 is true, we want to get our spline here and say remove spline point. And the spline point we'll remove is once again 2. We can remove any spline point because we're going to update it immediately after anyway, but we use 2 because it tends to be the one that's in the middle all the time, because you always have 0, 1, and the last and before last that you don't want to touch, and 2 is never that, or at least never that if we have this scenario, because we've always added a new one here. So if it is, we want to actually delete it and call this function after. So let's call that here, let's plug it here, and there we go. So for this function, it's a bit more complicated. What we're going to want to do here is we're going to need 2 of these. So let's just remove most of this because we're going to do a few things. Sorry, let's delete that. And we actually don't need this. Sorry, we need to say set spline, set location at spline point. Sorry, not that one. Make sure you plug it back into the remove. And we're going to need 2 of these. One for the initial value, so 0, and one for the other one. Now this time we're going to need them in world here, and we can actually recombine these. We're going to be splitting them after. We want to break both of these here, and we're going to be adding them together. So the purpose of this is, sorry, actually not that, U-1. We don't want the last index, we want the before last. There we go. So what we're doing here, just to give you an idea, is if we're close to the character, if we're close to the initial point, it means we're trying to make a very simple U shape. So what we're doing here is we're getting the middle point between that. So we're going to add and divide by 2, sorry. So like this, convert that to a float, and we'll say 2. And what we need to do is we need to also add it so that, because right now it will make a straight line, which is not what we want. We want it to actually add as well. So we want to do plus, and what we're going to do, because of how it works, if it's 180 degrees, that means we're facing the circle, the U at least, is facing in the direction of the forward vector anyway, and it will always be like that. It will never change. So all we have to do is get our forward vector, and we're going to be using it here. So we're going to do that, we will get distance, sorry, not that one, get this, sorry, between 2 points. And we're going to use our end, and we're going to use our before end and our second point. We're going to divide it by 3. So this is what I found worked best. And then we're going to multiply it by, well, our forward vector. So we're going to call that here, get forward, no, I don't think that'll work, get actor forward vector, and plug that in here, which will convert this to a vector as well. Connect that to the plus, and now we'll update our spline location. Now the point is number 2. That's what we're going to be actually moving here. Next, we want to set its tangents. So set tangents at spline point. Once again, same spline point to number 2 here, and make sure it's world. So actually, both of them need to be world here. Make sure that's the case. Next, so what we want here is, once again, we're going to need this, so we can copy paste it here. Do we need it in absolute? Sorry, so we do need this in absolute here. Same for here. And so what we need here is we want to get end quad, and we're going to want to get the y, and we're going to clamp it to 0.5 instead. And the reason we're doing this is just that we can multiply the distance, sorry, that we're going to get out of this by 0.5. So we want to get actor right vector here to right vector, because once again, it's always going to be the same position relative, because the rotation 180 is always relative. So that means it's always going to be a right vector and a forward vector aligned. So we're going to call this and say times, and we're going to have 2 pins, one for the distance and one to divide it by 2. We'll plug this into the leave and arrive, and we finish setting up our middle point. Next, we're going to go on false. So this is if we're either in front or behind the initial point. And so we're going to have to do very similar things down here as well. So as you can see, it's getting a bit long, which is why I mentioned the spaghetti. So once again, same thing as here. We want to call this, and this time it's superior to 6. So if it's superior to 6, what we need to do is that it means that the point is either far behind or far in front, where we're going to start turning. So instead of having it try and join as close as possible and then turn, we're going to add a intermediate point that is aligned to the x, y, if I remember well, of the starting point or the end point, and the z and the x of the other points, that it will be pretty much aligned with both of them. So let's get into that. So once again, we're going to get a new point. So we're going to call this pretty much again. Don't need to bother with where, it's going to work just fine. Attach it here, and we can move pretty much straight on. We don't need to worry about that. Next, what we're going to do is we need to know if it is in front or behind. So actually, let me just double check this. Yeah. So this will create our point, and then we will adapt the actual rotation once it's been added. So on false, it means we have our point, so we've already gone through this. But to be fair, this should probably be a sequence instead. So we'll call this like that. So if it's a sequence, we want to first check if we need to create our point. If we've created it, we immediately move on to here. We have another branch. Now the branch is going to use the same thing as this. And we're going to look for if x is superior to 0. So if this is superior to 0. If it's superior to 0, very simple. It just means that we're going forwards. Superior to 100, because we have another check before that does that. So if it's superior to 100, that means we're going in front. So we need to actually do it specifically aligned to the starting point, if I'm correct. Yeah, the starting point. So we're going to need another sequence here. And this sequence is going to go right here. And we're going to need another one at the bottom here, because we're going to do twice the same thing. So we're going to need to do two things here. We're going to need to move 2 points. So for the first one, once again, we'll get our spline here. We're going to say set location at spline point. And we're then going to say set tangent at spline point. Sorry, not tangent, but tangents. Tangents at spline point. So attach it here. There we go. Give it a bit of space, and maybe we'll move this slightly down. There we go. So for this, what we need to do is we're going to use this again. We're going to get both of these and we're going to break. So as I said, we're using the different values, and the point we'll use first is 1, and the next one we'll use is 4. And we're going to break both of these. Go. And what we'll do is we're going to make a new vector. So we're going to make vector here. And we're going to use the, I'm just double checking, we're going to use the y of the actual 1 point, and we're going to use the x and the z of the last point. So make sure we use local here. We're going to plug this into our in location. And then we're simply going to call our tangent here, and we're going to plug it into arrive and leave here. So make sure you use the top one, not the bottom one. I'll actually make a reroute, make it easier. Go both of them plugged in. So that will do it for the first part. For the second part, so the second sequence, we need to do the same trick as we did here, but we're going to get the middle point. So we're going to actually copy everything here because it's going to be identical, with the only difference being which points we actually interfere with. So here, instead of using this, we're going to say we're going to use point 2 and point 4. Sorry, 4, not hashtag. Leave them both in world. Same trick, we leave this, nothing to change. Here, we do the same change, 2 and 4. Move that. Here, we'll do the same thing, obviously. We'll take 2 and 4, again, move that. Number 2 and number 4. And we want to change the index to 3 here. And that should work, that should do the trick. So this is then going to be copied completely. We're going to do the exact same thing at the bottom. Actually, sorry, I made one. No, actually, we can do that there. Make the exact same thing here. Copy the sequence, attach it there instead of the old one. And the only difference here is we'll change the values again. We're going to use 1 and 3. The reason for this is because now the point is, instead of in front, it's behind. So we need to add one after the actual turn, not before. So the difference here is we also need to modify this and say it's minus sorry, not minus. We want to multiply it by a negative, so to invert it. So convert to a float, -1, and we're going to plug it into here. Destroy that. And so once again, we'll need to make some changes. We can leave this to 0 because we're only setting them. But for this, we need to change it entirely again. So we're going to be using, once again, points 1 and 3 this time. Did I make a mistake in the one above using 1 and 4? Let me just double check to be sure it's not a mistake. Okay, so using 1 and 4 is correct there. Okay, so the reason this works for 1 is because we want it to be the start point, so that's why. So here, 1 and 3 does work as well. So, sorry, so let me just double check. So the initial one here should actually be 1 and 4, not 1 and 3. But after it, it should be 1 and 3. So let's just, I'm just making 100% sure I don't get this wrong. So that's 1 and 4, and here we want to use 1 and 3. So the same here, 1 and 3, here 1 and 3. And instead of moving number 3, obviously we're going to move number 2 this time. So let's replace that, and there we go. Now, normally, if everything is correct, we are finished with our spaghetti code here, and we can move on to the visual. And once we have the visual, we can actually start to see if this is working correctly. So for the visuals, it's a lot shorter and a lot simpler, just a lot of stuff to actually do still. So the first thing we'll do is we will get our spline, and we're going to have to make a custom length. So as we made here, we have our section length, but we actually need to modify that, have a temporary one. So here we want to get spline length. We want to divide this by our section length. And usually this is enough, right? This can work for most scenarios, but in my case, I noticed that it didn't work too well. So we'll get a floor, and we're going to be using this with the same trick here. We'll get this, and instead of dividing, we will use a modulo to get what's remaining, the remainder of this division. And we'll then be using this divided by our actual floored value, and we'll be adding that to our actual section length that we chose. So it's 100. It should be 100 if you're using the same assets as me. And we'll promote this to a temporary length. So we'll promote that here and call L temp. So just put there, length. We can then drag this to our update sign. There we go. And we can get pretty much started. So we'll need, once again, this. We're then gonna truncate it this time instead of floor. And we're going to say -1, and this is going to be our last index. We're going to save it as that. So L last index. Write it here. And then what we want to do is we're going to say a for loop. And we're going to get last index here, plug it in. And what we want to do is we're going to promote our index first to a L current index. There we go. Apply it here. And now I'm not going to, we could do that. Okay, so then what we want to do is we want to set our static mesh, let's say. So I'm just going to skip this. Actually, no, we'll do it immediately. So first we want to get our current index, and we want to check if it is double equal to 0. We then want to call a select node. We'll leave it empty for now, so no type. We'll call another select here, which will also leave empty. And the wildcard this time will be current is equal to last. So if it's the last index, it's the last point, and we need to choose something different. Then we need to plug this into an actual variable, and we're going to have to make a local variable called L static mesh. So I just need to check the actual typing just to make sure. Okay, so the type is just very simply, just convert this back to a single if it is static mesh. The most basic one, this one here. Right it there, and we will set it here. This is just that as we go through, when we create our new spline mesh, we're going to be telling it which asset to use. So obviously, if it's the last index, we want to get the end one. So conveyor belt end. Let's just detach that and reattach it here. If we have our current index is equal to 0, then that means that we are trying to get the start point. So we want to get our start conveyor belt. If not, we want to get our mid conveyor belt. Next up is, well, we're going to be setting all this up. So next what we want to do is we want to get our spline mesh. We want to get its length, and we're going to check if we have already enough for this. So to do that, we'll say -1 to get its index. And we're going to check if this is superior, sorry. So we want it to be like this. And what we'll use here is current index. So if current index is superior to the current amount of static meshes we have, or spline meshes we have, then we need to make a new one. So we'll make a new one. So we'll go here, conditions for that, and we'll type here add spline mesh component, and we'll add a reroute here because that's where we're going to be going below and setting it up. So for relative transform, it doesn't matter, we're going to be setting up after. So let's set it up. So we have a few things to do here. First, we want to set a conveyor belt here. Now it doesn't matter which one because we're going to be updating it at the end, but we need to do it here anyway. So for the mobility, we need to make sure you set it to movable. If you don't, you'll be getting warnings and it won't work. For the materials, it doesn't matter, we're going to be setting them up after. For the collision, we need to make sure that everything is set to hidden, or at least we'll put it at no collision because we don't want it to hit anything initially, but we want to put it to custom. And the reason we want to put it to custom is we want to make sure that, no, we can leave it at this. So we might not even need to change that. So with this, we're then going to say set forward axis to X. We want to reroute this here, say it's because we're going to be moving, or at least needing it a bit more. Next, we want to say set material. And we're going to need 2 of these because there's 2 materials for each of these actual static meshes. So let's call it again here, attach it like that. And so for the index 0, we're going to put our default, no. In this case, both of them, no matter which one they are, they're going to be the hologram material. So just align it like that. And then what we want to do is we want to promote this to a variable. So this will be L current mesh components. So comp will do. And we're actually going to need to do the same thing at the bottom here, because we need to tell it if we don't need to create it, we do need to get a reference to the one that works, that is at the spot. So to do that, we will get our spline mesh here. We're going to say keys. So to set it up on the other side, we need our keys. We're going to attach it here, and we want to use the get function simply, and we're going to get our current index. We can then apply this to our current mesh like this. And if this isn't set correctly, as in you can't attach it, then it's likely that this isn't the right type. So just be careful with that. We then want to go and add a reroute here and connect the 2 of these together like that. There we go. And what we're going to do here is we're going to start off by adding the actual function here. So to do that, what we need to do is we need to add it to our spline mesh. I didn't say that very clearly. We want to add. So the reason we're doing that is because we're going to add like this, our current mesh, right? But the reason we do this as a map and not as a simple array is because we need these 2 values to be used as the start and end points when we're going to be doing the check to see if the actual conveyor belt is buildable. So what we use for that is simply, we're going to be using the distance at the start of it and at the end of it. So to get that, we get our temp length, we get our current index, and we multiply the 2. That will give us our starting point. For the ending point, it's pretty much going to be similar. We'll be using this, except instead of this, we want +1. Attach that here, and I'll deal with our add. So next we need to do what will actually orient the actual conveyor mesh. So we want to call this, and we want to call set start and end. So this is what we're looking for, this one with 4 vectors. So to do that, what we need is we're going to need our current mesh, and we're going to need our temp length. So what we need to do here, normally what you could do is you could use the, well no, you can't do it because we actually use distance here. So we need to use our spline again, and we're going to get location at distance this time instead of at spline point. And for the distance, we'll simply use this times that. Plug that in here and make sure you use local. So this will do for our start position. Just move this up a bit. For the tangent, we'll do the same trick. We'll use our spline as well, but instead of get distance, we're going to want to get tangent at spline, at distance, sorry, along spline. Attach that here, and once again keep it in local. Attach it here, and we want to duplicate this, and we're going to use the same thing, except instead of current, we're going to be using the +1. So +1 here. But to be fair, to make this easier, we could just do that. I'll make it a lot easier. There we go. And so this will do the trick for the actual end. And with that, we finish our visual. So let's give it a try. Let's see if everything is working as intended. So we place, and that doesn't seem to be right now, does it? So this is not at all doing things correctly. So let's have a look. So that's not what it's supposed to do. So I think I have an idea why that's happening, but I'm not 100% sure. I'm just gonna have to double check here. I think what's happening is, yeah, it's not deleting them. Oh, sorry. I completely forgot. We haven't even finished. There's still this to do and this to do. So that's me being a bit in a rush. So on the sequence, we need to call our current mesh comp, and we want to call set static mesh. And we're going to use the static mesh that we made before. So then the last one we need to do is for the actual for loop at the end. So what we need to do at the end is we need to get rid of anything in here that is extra. So we need to call length. And with length, we're going to say -1 to get the index again. Sorry, not 11. And we want to say if you are superior to the current index, or we can also use the last index, but we'll use current index. If you're in that scenario, if you're superior, then that means we have too many. So we want to get rid of those extra components. So what we'll do is we'll set our current mesh to empty again. We're going to go through our keys here, and we'll have a for each loop run. So let's just drag it there. So get a for each loop, connect it all up. And for the for each loop, what we'll simply do is we'll look if the array index, sorry, no, we don't want a for each loop, we want a reverse for each loop. I have to do this because we're deleting it as we go through the array. So if at any point the index is superior to our current index, so that means if ever we are superior to it, then we want to actually remove it. So we'll have a branch here, and we will say remove the current one here. So to do that, we actually need to set it first on true. So we need to call this here, we'll add a reroute node because we need it a bit more. And we'll say from here, we'll say remove. And the reason we have to do it this way is because when we remove it, it doesn't know what it is anymore, which is why we have to set it to our current mesh before. So then we can call destroy component. And on false, we'll do a return node to stop the loop because we don't need it anymore, because we're actually at a value which is the end. So that should be everything we need to do, and let's give it a test. So that still doesn't seem to be doing the trick for some reason. We're I feel like we have it correct. It's just that for some reason we shouldn't be having all of these, because right now we're going straight in the right direction. So there's no reason to have these extra functions here. Maybe, oh, I know why. I completely messed up. In our update spline shape, I left this as 0, didn't I? Okay, so that should be 180, obviously. So that was just creating extra points for nothing. So if we do this now, we still get... So we still have our spline. Our spline is working as intended. We just seem to have a bit of an issue here. So maybe I messed something up in here, and this should be different slightly. Let me just have a look. Okay, so one thing I did do, let's check if that's the reason. I put a clamp here to make sure that it didn't get too long, or at least so it didn't get longer than the actual temp value here. So we'll do... So let's put it for both of these. For minimum, we can leave it at 0. Start tangent, put it there. Let's try this again, and hopefully that solves the issue. And it does seem to do that. So what it was doing is the actual tangents were too long for what it was looking for. So as you can see, it works perfectly fine. So now what we're going to be setting up is that if you have this, you can't actually place it, because if you place it like that, it will look very weird. Okay, so also we have apparently another problem. So I think I know what happened there. In our place build, I forgot to tell it here, to return. So make sure that when you have the final sequence here, you press true here. So this is in the place build. Make sure you have it true, otherwise it'll think it's still false and still trying to place. So let's show you again. If it looks like this, you'll have like a weird kind of effect that we absolutely do not want. So that's going to be where we tell it it's not buildable. So to tell it if it's not buildable is the next step, and this video is getting very long, and I apologize for that, but this is just how long it takes to make something like this, sadly. The IsBuildable function is about as long as the one we just made. So what we'll start off with is a branch, and so make sure you don't delete this, but you keep it for now. And on false, so actually no, we'll use our macro here. That's the whole point of it being here. We'll use our macro. If we're doing the start, then we don't need to bother with all this difficult stuff we'll do after. We just want to know if it's buildable with the base class function. On the other hand, we'll need a few other checks. We'll do a few checks before the more complicated one. So the first one we'll do is we want to check if the actual thing is too short. Because if it's too short, we don't really want it, because it can cause some issues, especially visually. So and it's a bit difficult to... Well, you can use the other functions after, but it's just a symbol because it rarely ever works when it's this short. So we're going to get a spline reference, So grab it here. We're going to get spline length. And what we want to check is if it is superior to 300. But we also want to check if, when we say superior to 300, or we want to check if it is straight, or more like if it is... How to put it? What we want here is, let's just add it. We'll get relative rotation, and we'll say nearly equal. If it's nearly equal to 0, and our relative distance, if I'm here, so get relative location is nearly equal as well to 0, then we don't want to do this. If both of these are true, then it's bad. Okay, so this is actually a particular case where if we have a rotation, I'll show you what it is. If it's like this, it's a bit too short, so it won't look too good. Actually, something's wrong here. That should be the other way around. Let me just double check that. So that's an issue we need to fix really quick. So if I remember correctly, that should be from here. So there's a little mistake here. First off, I moved these around. It was the other way around. But the point index shouldn't be 0, but should be 1. And that should fix our weird issue here, where if we did that, or not, and made it worse, apparently. Sorry, why did it do that? That's very strange. Okay, so Okay, so something's wrong here. Normally this shouldn't be doing that, but what we're trying to do is that. So if this works correctly, this works correctly, so I'll have to go back through it again just to double check. This is the result we want. So let's finish with the IsBuildable and then we'll see what's wrong here. So for IsBuildable, we need this. This is just to check that if they're close by, if they're both aligned the right direction, then it's fine. We can leave it as is. This happens. So if it's false, we want to return node false. For the next one, we're going to do another check here. So this is going to be if it's too short. Just put a little note there. This one is going to be if it's too steep, because that can also be an issue. So to do that, what I did is we're going to get last spline point. We're going to get spline info at point, which is our custom function. And we're going to, well, we can split that, it takes up less space. We're going to normalize our location. And we want to get linear distance of spline. And what we'll do with that is we will divide this by the total distance, and we will break out our node. And what we want to look for is specifically the Z. We don't want it to be too high. So the value I found was we want absolute, because if it goes down or if it goes up, it's the same rule. We don't want it to go too high or too low, in too short a distance at least. We want to check if it is superior, like that. If 0.0, no, sorry, I was right the first time. We want 0.0007. So this might need some filling. In my case, this was the value I found, but it could be wrong for your version if some other things are a bit different. So on false, we want to return node, leave it false. And for the mesh, we're going to go here, get our keys again, plug that into here. And what we'll want to do is a for each loop where we're going to get a reference to our spline point again, and we're going to promote this to a variable. This variable will be called L current spline mesh again. Plug it in here, and what we want to do is we want to set its collision to disabled. So the reason we want to do this is what we're going to do is we're going to check if they're overlapping each other. So we can actually do that because each spline, at least from my understanding, each spline mesh is different from another, so they can collide with each other, which is the scenario we had before, which I showed where it looked really strange. If that happens, we'll be able to detect it with a box collision that we're going to set up now. So we want to get this here. We want to get our custom, our local variable, and we're going to say find here. And with the find, we then have our actual coordinates, or our lengths, more like. So we're going to promote this to a variable too, which we'll call L current spline mesh data. So let's attach that here. That's no collision, good. Actually, when we finish this, we will return true. That means there was nothing nothing bothering. We can actually move forwards. So we want a sequence here. We want 3 points. The last one is pretty simple. We want to get our spline mesh and re-enable its collision. So set collision. And I think it's query only because we don't need physics for this. So next what we're going to do is our box trace. Now the box trace is a lot of nodes. So I'll try and make this as simple as I can. It's a bit of a mess on my screen. So we'll split this. I'm going to need it twice. One reference to our spline again, and a reference to our current spline mesh. So we'll get our box trace by channel. There we go. And let's just plug it in here. And what we want to use is, well, first we'll add our ignore here. We want to make an array because we need to actually ignore some things, and those some things are our start support and our end support. Sorry, I replaced it. Start support and end support. Now I'm going to be using twice pretty much the same here, so I'm just going to make a duplicate of this all once we're done. On the output, we simply want to branch. If we hit something, then we can stop all this and just return false, that it's not buildable. For the rest of this, for the start point, or at least the start, oh, I keep doing that, let me stop doing that. We want to get our current spline mesh, we want to get start position. And with our start position, we also need our get actor transform here, because our box trace is done in world space, whereas this is in local. So we need to convert it. So we'll say transform location, and we're going to plug that in right there. This is going to be almost our start. We need a little bit more. So we're going to add two things here. First one, going to go there. Obviously the end, sorry. And next what we need to do is do the rest, so the different additions. So we're going to need two here. And we can also do this for the actual end part. For the half size, what we want is we'll want 0.49, 49, and 1. The orientation, we're going to set it up in a second. We want to trace complex and ignore self to be unticked, sorry. Because otherwise we won't be hitting our own actor, which is the whole point of this thing. So what we want to do is we're going to use these, because these are being, what we saved here was the actual points where they start and where they end. So what we want is with this, we'll say get up vector at spline distance. And the spline distance we want is X, because X is the beginning. We'll then do the same thing here for the get direction at distance, which is pretty much our forward vector. We want to get our X again. Both of these need to be put to world. There we go. And so for the up vector, we want to multiply it by 5, and we're going to attach it to the end point right here. But we also want to use these to get our actual, how to put it, our direction. So we're going to make rotator from Z and X. So Z is our up vector and X is our forward. And this will give us our orientation. And we want this to go here, and we also want it to go here. So we have X here, which we're adding 1 here. So we're moving it slightly inside of its own collision, so that if anything is overlapping with it, as in inside its collision, we'll be able to detect it with this box trace. Now, we can pretty much copy this, because it's almost identical for the second one. So we're just going to connect it here, and we'll make the small changes. So we'll keep the same current mesh, obviously, but instead we want to get end position. So we attach this instead. For the end position, instead of plus, we want to do minus here. So 3 times minus. And so we plug our 1 here and our 1 there. For the plus here, for the end, we want to keep it as a plus because we want to, because this will just go up. So we always want to add. And obviously the distance, because we changed to the end here, we need to change it to the end here as well. And that should do the trick for this, for our detection. And let's give it a try. So if we have 2 here, as you can see here, it works pretty well. This is too short, which is why we're getting an error. If we go further, it works. If we go here, it's fine as well. But if we go and try and do too short, oh, no, apparently it's not detecting it. So maybe I messed something up in the collisions. So this is the issue. So the issue is that in our add spline mesh, we've told it to ignore our actual visibility. So it's not even detecting it. So we do need it to be custom. And we want it to block this, but we don't actually need it to have collision on these, because otherwise it's going to hit the actual player. If I'm okay, no. So this should work just fine if we leave it all as false here, or as solid. Sorry. So let's do another test. If we go here and go back, yep. So now it's actually noticing it. It doesn't perform any extra tests. It's just going to do this one and say, well, it hit something. So there's no point in testing anymore. It did hit something. So it seems to be working. We do need to update it here and tell it to actually change the material for the supports as well. So we'll have to do that very quickly as well. So let's just really quickly go and do that. So in our IsBuildable, we don't need to change it. It's all functional now. We can just hide our debug types, and we need to tell it inside. So we're going to leave this, no, not this one. We'll leave this one open because we're going to need to check why it's not working correctly. But in our update location, right here, we can do the same trick normally. We can tell our spline here to set all materials right here. We're going to get our MI hologram as well. And we're going to tell it to set it for our start and our end support here. So I don't know if that will work. That does work. Perfect. Let's just give this a bit more room. And so now these will be linked to the same material as the other ones. And so we can do that here. And we can run another test if we do simply there. Yep, so now it tells all of them to be the correct color. And if we place it, so we can't place it here, it won't let us because it's not valid. But here, no problem. And as we can see, it moves. So obviously, I'm not a 3D artist, so these things won't, the UVs are not perfect. That's why you have this weird kind of glitch as far as it moves. But overall, you can tell that it's moving. So that's the whole goal. If we try and, for instance, make it go up a steep hill like this, it's not going to let us. It's going to say too sharp. But if we do something like that, it will work. Although it's worth noting that we haven't set anything up to manage with collisions outside. So this does work, as you can see, but it does go through the wall. But that's going to have to be for our next part because this is getting already a bit too long. So let's try and figure out why we have that issue here, where if we invert it, it goes completely messed up. So in this one here, at the end here, where we say if it's in front, I thought it was a good idea to leave this as 0. So that is not correct. It is not 0. We can't leave it at 0. That will cause a massive issue. So we need to change this right now. So I'm just going to get it open on my other side because I know it's correct over there. So if it is the before last one, so it should be right here. Okay, so it should be number 2 right here. Am I still calling number 0 somewhere else that I may have forgotten? Okay, it's because it's a copy and it still has the issue. So this is number 3, not number 0. So compile and save, and that should, if I'm correct, have fixed it. Okay, so I think it's doing that because I'm in the way. So that's the final result. That's what it should do. And if we go ahead and, for instance, move here. Okay, so it's not finished yet. It still has some issues. Let's try and figure out what those are. So I made a mistake. The get number of splines points here where it's 5 on the inferior, equal, or in between 100. It shouldn't be inferior. It should be superior. So this is pretty much if you move back, let's say, it will get rid of the other points. That was not necessary. So pretty much the glitch we were seeing. So if we go here, we have our 2, we have a curve like this as intended. But if we go here, we lose that extra point that we had before, and it realigns perfectly. If I go further here, it shouldn't be doing that, that's for sure. So the reason is once we copy this, this is aligning the 2 different points relative to which one it is. So we need to inverse this. So this needs to be X and Y needs to be the new one. And that should solve this issue as well. Sorry, there's so many issues, but this is kind of complicated one. It's very long as well, so I'm doing my best. And as you can see, it works now as it should. And we can go back and forth. Here it won't look too nice because it's too close. But if we move it a bit to the side, it will allow it to work and it will be visually correct. So I think that does it for everything. I don't think there's anything else that needs to be done. It's perfectly functional, working as intended. In the next part, we might look at making the actual proper IsBuildable function, because currently you can actually still kind of go through walls in certain scenarios. So maybe not this one because it's hitting with the points, but as you saw earlier, we can do increasing in height as well. And we have a moving conveyor belt. It all works just fine. So thank you for watching. I apologize, it was very, very long, but that's just how much time it needed to get this done, which is why I didn't do it in the last part. But thank you for watching. Hope you enjoyed, and I hope you look forward to the next part. Goodbye.